everyone, myself Bhanut Rahul. Today I am going to explain about computing edge. Introduction to computing edge. Computing edge refers to processing data closer to the location where it is generated. It reduces latency and improves real-time data handling capabilities. This approach is increasingly vital with the growth of Internet of Things of IoT devices. Here we can see in the image edge computing, cloud computing. Both are comparing with both are images are there. Resources and edge computing a distributed computing paradigms that process data closer to its resource, reducing latency and improving efficiency and for applications like IoT devices, autonomously vehicles and smart city. Edge computing brings computation and storage closer to where data is generated, allowing for real-time analysis and faster decision making without relying solely on centralized cloud infrastructure. Here you can know what is edge computing. Edge computing involves deploying computing resources at near data resources. It enables faster decision making by minimizing data transfer to centralized data centers. This paradigm complements traditional cloud computing by addressing latency issues. Here the key aspects of edge computing from we can see definition. Edge computing is a distributed computing architecture that brings computation and data storage closer to the location where data is generated or needed rather than spending it all to a distant centralized cloud. Here are the benefits we can see: reducing latency, bandwidth optimization, enhanced security, scalability. These are the benefits of computing edge. First, we can see reducing latencies. Process data locally leading to quick reason time, which crucial for real time application. Bandwidth decreases amount of data transmitted to the cloud, saving bandwidth or cost. Enhancing security, it means sensitive data can be processed and stored locally, reducing the risk of the breaches during transmission. And scalability allows for easier to scaling of computation services to accommodate numerous devices that data volumes. These are the key points of edge computing. Edge devices such as sensors, gateway, and local server collect and process data. And edge infrastructure includes hardware and software that manage local data processing. Connectivity solutions like edge devices to central cloud system for data synchronization. Here you can clearly see in the image benefits of edge computing. Now only you have seen benefits of edge computing. These are the main benefits of the edge computing is reducing latency, bandwidth optimization, enhanced security and scalability. These are the benefits of edge computing. First, we can see what type of benefits of edge computing. It significantly reduces latency, enabling real-time data analysis and responses. Edge computing decreases bandwidth cost by processing data locally before transmission. It enhances data privacy and security by limiting sensitive data to explore to centralized servers. Edge computing, you can see in the image, edge computing architecture. You can see clearly data warehouse, business logic, big data analysis, big cloud platform for layers, data analysis, data reducing. By data reducing, we can clearly normalize the data and we can improve the data efficiency. These are the challenges. These are the challenges in edge computing. Managing and maintaining numerous distributed edge devices can be complex. Ensuring data security across multiple locations is a critical concern. Scalability can be challenging as the number of edges devices grows rapidly. You can see before that applications of edge computing edge is a particular beneficial for application requiring low latency and real-time processing such as autonomous vehicles, smart cities, industrial automation, and Internet of Things in IoT devices. Relation for fog computing. Explain fog computing is a concept closely related to edge computing, often considered an extension of cloud computing to the network, facilitating servers between end devices data centers. Edge computing uses how it will be used in the real life or in the day-to-day life. Autonomous vehicles rely on edge computing for immediate data processing and decision making. Smart cities utilize edge devices for traffic management, surveillance, and public safety. Industrial of IoT applications use edge computing for predicting maintenance and automation. Here you can see in the image you edge computing use cases explained now only. Edge computing with cloud computing. Edge computing processes data locally, whereas cloud computing handles centralized data. The two paradigms often work together to optimize performance and resources utilization. Edge provides low latency and real-time insights, while cloud offers extensive storage and processing the power. Future trends in edge computing. Integration with 5G networks will enhance the speed and reliability of the edge solutions. AI machine learning models will be increasingly deployed at the edge for intelligent processing. Edge computing will become more autonomous with advance in management and orchestration tools. Visualization trend series. What is edge computing? Like that. Implementing edge computing solutions. Organizations such should access their data processing needs and identify suitable edge devices. Security measures must be integrated at every layer of the edge infrastructure. Collaboration between cloud providers and edge hardware vendors will be facilitated seamless deployment. Edge computing technologies aim to making Internet of IoT with 100,000 of sensors in the next decade. With the increased usage and manipulation of large data, it becomes important to get used to this technology, which refers to computing on sensor itself. 2019 is rated as the year of edge technology and will remain so in the coming years in a variety solutions or situations. Edge computing is deployed. One is when IoT device is centrally connected to cloud due to poor connectivity of device. By year 2020, there will be approximate 1.5 GB worth of data is generated per day, with many devices connected to the internet and generating data. It's not possible for cloud alone to handle this huge data all by itself. It can be related to data processing as well as the local processing of real-time data. The various edge components that can be counted upon are data processing, rule, rule engine, local database. Cloud is more concerned with big data processing and data warehousing. You know what is data warehousing? It stores the large amount of data for the company growth purpose. Whatever the data storage area, we can also call data repository. Why edge computing? This technology increases the efficient usage of bandwidth analysis and that data at the edge itself, unlike the cloud which requires the data transfer of data from the IoT requiring large bandwidth, making it is useful to be used in remote locations with minimum cost. It allows smart applications and devices to respond to data almost at the same time, which is important in terms of business and self-driving cars. Implementing edge computing solutions. Organizing should be assess their data processing needs to and identifying suitable edge devices. Security measures must be integrated at every layer of the edge infrastructure. Collaboration between cloud providers and edge hardware vendors will facilitate seamless deployment. Here we can see conclusion and key takeaways. Edge computing is transforming data processing by bringing computation closer to the data sources. It offering significantly benefits in latency, bandwidth, security, and reliability. Embracing edge solutions is essential for modern applications like IoT, autonomous systems, and smart cities. What are the different types of computing? These are the three types of different computing: edge computing for basic event, edge computing for complex event, edge computing for servers. These are the three things. Thank you.